Hey guys, what's going on? We're back with day 21. Today we're going to look at some more implicit differentiation. So let's get right into it. Here's what we have. We have an equation 3x minus 6xy squared plus 2y equals negative 4. And we want to find the equation of the tangent line at the point 2, 1. The nice thing about implicit differentiation is they usually give you both coordinates of the point, x and y. So we have the point, right? We know the point is 2, 1. So we can get right into the derivative. So what we're going to do here is we're going to do the derivative. We're going to plug the point 2, 1 in to get our slope, and then we can write our equation for our line. Going through and doing this derivative here, it's implicit, so I have to remember the dy dx thing. Also, I see a product rule in here. Okay, when we look at this product rule, I want you to think of the first term as negative 6x, and the second term as y squared. What's going to happen here with this product rule is both of these things are going to be negative. Okay? You guys did a good job of picking that up in class today. There's also a simplification piece that's going to be important to look at. So I chose that for a specific reason. Now let's go through and do our derivative so we can plug the point 2, 1 into our derivative to come up with the answer. Okay, the derivative of 3x is simply 3. That's easy. Now I have to execute my product rule. So I'm going to do the derivative of the first, which is negative 6, times the second, y squared, plus the first. It is plus because it's product rule, but the first I'm thinking of is negative 6x. So instead of writing plus negative 6x, I'm just going to write minus 6x. Times the derivative of the second, which would be 2y dy dx. I really don't like having this 6 and this 2 right here. I am going to simplify that on my very next step. Okay, but I'll get there when I get there. But that reads correct. It's 6, right? It's minus 6 times x times 2 times y times dy dx. Okay? So that's the end of my product rule. I did the derivative of the first times the second plus the first times the derivative of the second. I need to continue my derivative now. The derivative of 2y is 2 dy dx. Equals 0. All right. Now I want to take a second right now to rewrite this thing because that 6 and that 2 is bothering me. Okay? 6 times x times 2 times y times dy dx can be more easily and simply written as 12xy dy dx. So I'm going to do that right now. Now I have a choice. I can move my dy dx's to the other side, or I can keep my dy dx's on the left side and move the 3 and the minus 6y. I'm going to move the dy dx's. I'm going to leave the 3 minus 6y squared alone. And I'm going to add over the 12xy dy dx. And I'm going to subtract over the 2 dy dx. That kind of keeps things nicely with a positive term being first and the negative term being second. Then I'm going to factor and divide. I'm going to get dy dx equals 3 minus 6y squared over 12xy minus 2. Now, when you're evaluating, it can help, especially if you're not using a calculator, it can be helpful to simplify here. But when I look, 2, 6, 3, and 12 kind of looks like there's something that divides all of them, but there isn't. 2 would divide 12, 6, and 2. 3 would divide 3, 6, and 12. But no number other than 1 divides all 4 of those. They don't all have x's. They don't all have y's. So that's as simplified as I can get it. Now, again, I want you practicing this notation. Instead of just plugging in 2, 1 right now, I want you to practice this notation. That's our notation for evaluating the derivative at the point 2, 1. So instead of just saying equals 3 minus, right, let's write that notation. Let's practice that notation tomorrow. And here's what we're going to have. We're going to have, again, this is x, this is y. We're going to have 3 minus 6 times 1 squared over 12 times 2 times 1 minus 2. 1 squared is 1. 3 minus 6 is negative 3. And on bottom, 12 times 2 is 24. 24 minus 2 is 22. And that doesn't simplify, so my slope is negative 3 over 22. So the equation of my line would be y minus 1 equals negative 3 20-seconds, x minus 2. I want to show you a couple of examples of implicit differentiation where the chain rule comes into play. Okay. So here, when I take a look at finding dy dx here, what I see is a chain rule, because I see a function xy within a function natural log, ln. I also see a product rule in here as well. So we have to be very careful when we do this, and we're still doing implicit here. So there's a lot to kind of be careful of here. Let's take a look at it. The derivative of the natural log of xy, right? Whenever we're doing the derivative of the natural log of something, the derivative is going to start, we're going to do the derivative of the outside with respect to the inside. Not 1 over x, but 1 over xy. And then we're going to multiply that by the derivative of the inside. Right? Again, this is my inside, this is my outside. But the inside is a product rule. When I go to do the derivative of the inside, I'm going to do the derivative of the first, which is 1, times the second, which is y. I'm not going to write the 1. Okay. Plus the first, x, times the derivative of the second, dy dx. And that's the correct chain rule. Derivative of the outside with respect to the inside times the derivative of the inside. Now, the derivative of the inside required a product rule. Okay. So that's the complete derivative there. Now I have to do minus 6x squared equals 0 to finish off that derivative. Okay, I'm going to go ahead and rewrite this thing. To solve for dy dx here, there's kind of a lot going on here. So I got to isolate dy dx. It's going to take a lot of algebraic skill to do that. First thing I'm going to do is I'm going to write this thing. Oops. I'm going to write this thing as y plus x dy dx over xy. Now I want to get rid of that fraction, so what I'm going to do is I'm going to multiply both terms, or I'm going to multiply both sides of the equation by xy. And that gets distributed to both here. It's going to cancel right here to leave me with y plus x dy dx. Minus 6x squared times xy would be 6x cubed y equals 0, because 0 times xy is still 0. Okay. Now I'm going to start isolating dy dx. I only have one dy dx. I'm going to add the 6x cubed y and subtract the y, and I'm going to get x dy dx equals 6x cubed y minus y. And then I'm going to divide by x to get dy dx equals 6x cubed y minus y over x. And that will be my final solution. Okay. Let me show you one more problem, and then we'll call it a day. Once again, I see a chain rule here. Please don't think of this as a product rule. It's not sine times y cubed, it's sine of y cubed. Y cubed is embedded within the function sine. So it's going to be a chain rule. I'm going to have a chain rule here. And I have a product rule here. So go ahead and solving this. I'm going to do the derivative of the outside with respect to the inside times the derivative of the inside. Well, the derivative of y cubed is 3y squared dy dx, because I did a derivative of y. Derivative of the outside with respect to the inside times the derivative of the inside, remembering that anytime I do the derivative of y, I need to multiply by dy dx. Plus, product rule here, 2x is my first, y is my second. The derivative of the first is 2 times the second is y, plus the first times the derivative of the second. Gives me my product rule, and I get 10 for my derivative on the right side. Now, cleaning this up, I always write dy dx at the very back. I'm going to write this first and this second. So I'm going to call this 3y squared cosine of y cubed dy dx plus 2y plus 2x dy dx equals 10. I'm going to keep my dy dx as put and subtract away that 2y. So I'm going to get 3y squared cosine of y cubed plus 2x dy dx plus 2x dy dx equals 10 minus 2y. Then I'm going to factor and divide, and I'm going to get dy dx equals 10 minus 2y over 3y squared cosine of y cubed plus 2x. No simplification necessary here because the coefficients don't have a common factor other than 1, and they don't all have x's or y's. All right, that's it for today. I will see you guys on Thursday tomorrow. Talk to you later. 2 chains. Bye.